Ah, shit just got real. Greetings, the Astro 30 here, and welcome to part 7 of this Class D amplifier build, where I build these silicon chip Class D, Classic D modules into a case. This is a project by John Clark from Silicon Chip, by the way, and this is the second power amp module, and I've just built it, and yeah, there's a little bit of an issue with that tube of heat transfer compound going all over the place because it's all runny as an egg. The holes in the heatsink are drilled slightly off. I mean, I measured it and that one is 13mm instead of 12.5 between the two hole centers, but when you look at it, all transistors are leaning over towards the right anyway, so it doesn't really matter. Anyhow, in this particular part, I'm going to be finalizing the electronics, and one part is testing the power amp. And the other two parts will be remaking the tone amp board and the volume control board, respectively. Now, with the tone amp board, I have managed to shave 8mm off the right-hand edge, so it should clear the pot just nicely. But I do have an idea of how I can test that theory without having to waste any PCB material. We'll get to that a little bit later. First of all, I've got everything hooked up as it should be with jumper wires, like LK3 is shorted. We've got LK2 in the normal position, ground lift is set to shorted, and we've got a jumper across the protect output socket LK4. And first thing to do is connect across COM and VR1 test point 1 and adjust that trim pot here to 850 ohm, I believe it is. Yes, 850 ohm. I think in the last clip I said COM, I meant ground. So currently we're at 1.067k, so we are reducing. So if I turn it in the counterclockwise position, it drops down. So we want 850 ohm, thereabouts. And then I'll stick it on an oscilloscope and adjust it to the 500 kilohertz that I need. Where are you? Come on. 851, that's close enough. Alright, the next step is to insert the fuses, obviously, and connect it up to the suitable power supply. Now, I haven't got my toroidal 300VA transformer wired up to the power supply yet, so I'm just using those two transformers wired in wired in series there with a bridge rectifier of its own on it, just to power the power supply. And what we expect to see when we plug it in is, with all the jumpers set to the current configuration, is the red protect LED here light up. If that lights up, it should all be pretty good. Then I've just got to go around and measure the voltages on various test points. So first I'll plug him in and we'll see if it goes bang. Hopefully not. Here we go. And I can see the protect LED is lit. You may or may not just be able to see that, but it is lit. So nothing untoward's happened yet. We just need to check that the plus minus 50 volt rails are there or thereabouts across that connector. Going to go from negative to 0. Got 44 there, and from 0 to positive got 44 volts. So the voltages are there. I don't know if you saw it on the meter, but they're there. So I know that it's not loading the power supply down. 44 volts is roughly what 30 volt AC is, multiplied by 1.414. So now, step 7 is I need to check the VCC between that and COM is around 14 to 15 volts. So between VCC and COM, we're at 14.3, that is correct. Now the output across the speaker terminal should be around about 1.57 volts, thereabouts. 1.53, perfect. Now I need to check the voltage between VB and VS over here. That should be around 9 volt, but will rise to 14 or 15 volt when the amplifier is actually running. So it should be 9 volt when it's in protect mode. 8.6, close enough. So now that I've checked all the voltages, I can, and they're all correct, or within, you know, plus minus 500 millivolt, I can now switch off, remove the protect jumper on LK3 and of course across LK4, and the protect LED here should light instead of the the run LED should light rather than the protect. If all is well, it should light up after about 2 seconds. And bingo, that means the amplifier is running. So that's another working module. So it is now safe to assume that it can be hooked up to a speaker. I'd like to hook it up to an oscilloscope just to, you know, verify the output. But really, all that's really necessary is to hook it up across the speaker and see if it makes a noise. Okay, got it hooked up across the speaker. Let's turn on. Just a little bit of a tiny pop there, nothing really unusual. So I will hook up an audio input. I can hear it's working straight away. Yep. The old blurt test tells me that it's working. So I will hook it up to a dummy load in the DDS and we'll just verify that it's producing a amplified output. It's not just, you know, doing nothing. So I'll just use the small DDS for that. The small DSO for that, and the large DSO when I want to do the calibration of the frequency. Okay, everything's set up. DDS is at 5 volt, peak to peak output and 1 kilohertz. I think the input sensitivity of this amplifier module is 5.6 from memory. DSO hooked up in the background there. So all I've got to do is basically power the amplifier up. And we'll see if we get an output on the scope. Now I'm in times 10 mode on the probe and I'm at 5 volt per division. Apparently it does. Now I just need to adjust this so we can see the frequency. And we got a voltage peak, output peak to peak I should say, of 73 volts. So it's working. Everything is good there. So what I might do is I'll put this into sweep mode. Start out at 75 volt, drop down to 70, drop down to 68. Yeah, so just rolling off a little. So I know that that's working okay. Okay, so I know that it's functioning, so I can unplug the power supply. I can probably unplug the DDS and I can get rid of the oscilloscope now. And there it is, the second module, now in its new home. And it looks better with it all completely assembled. You'll notice there's a red RCA plug and a black one sticking up. That's just, you know, for somewhere to put them so I don't lose them. Now I can move on to the tone amp and the volume control board, and I'll probably end up wiring up the high side as well. That'll be done tomorrow because today I've got to go to work this afternoon, so I'm not going to have time to do it. But tomorrow I'm going to spend all day wiring up the high side, doing the etching of the tone amp board, the volume control board, putting that all in on the front panel and put the headphone amplifier board back in. And get wires run so I can go to the 15 volt side, and yeah, we'll basically play it by ear and go from there. And once I get all the electronics finalised, then it's just a simple matter of drilling the back panel, marking off the front panel and the back panel, screwing them both on, putting the lid on and putting some feet on it, and it's done. But I'm still waiting on my large volume knob, so that's not going to come for at least another couple of weeks yet. So I've got 2 weeks to muck around with doing the front paneling labelling and the front panel labelling, and also the back panel labelling and drilling it. The drilling of the back panel will be done in another part, not in this one. So anyway, without me talking about it, moving on. Okay, so how am I going to determine if this new tone amp is going to fit without wasting material? Well, that's simple. I've got a piece of cardboard here, and I've also got the printout in the incorrect direction, as looking from the top, component side, of the tone amp on a piece of self-adhesive label here. So what I'll do is I'll cut the label out around it, stick it to this piece of cardboard, and then cut around the board edge pretty much well on the line as I would be if I was cutting the board, and probably shove a potentiometer of this size through its holes to make a mock PCB, as it will. The thickness of this is not quite the same as the copper clad. It's probably half a mil too thin, but it'll do for process of example. So first, I will cut out the artwork so it's a little bit more manageable, and I will stick it to the cardboard after peeling off the backing. And it doesn't have to be perfect, it just has to, you know, work. I reckon that's going to be appropriate enough, and I'm going to carefully cut along my board edge. It's just what's used in the bottom of a Coke box that cans come in, I suppose. So it's going to serve this purpose just nicely. The back edge is not really all that important to me. Now there's crap on my floor. Done. And there we have a visual representation of the finished PCB. So if I put it in here, the correct way round might help. Yeah, so that goes in there like that. Okay, I reckon it should. Going to take a dual gain potentiometer that I have lying around, and I'm going to poke it through the cardboard roughly where the pot is, which is a little bit more difficult than it looks. There we go. So that's pretty much what I want. I'll take off the mounting hardware because I don't need it at the moment. Get out of there, you bastard. Alright, I'll place him, this pot where it goes, which is there. It's not going to stay there. I'll take my pre-made volume board that I've made previously, bend that out of the way, poke that where it goes, and I can see immediately that that is going to clear nicely if that was all the way down, which it is. Yep, that's going to clear nicely. So I don't have any problems with making up the PCB now. That should no longer interfere. I don't have to redesign the PCB any further. That's going to work nicely. I'll give you a back view now. If I put this nut on so that this piece of cardboard is held roughly where it needs to be, or within the ballpark, straighten that a bit. I don't know how well you can see that, but the cardboard, even if it was hanging down at an angle like that, will clear that pot just nicely. There's not a lot of room with everything mounted in here now to actually see everything, but where my finger is where the pot is, and I can still move this piece of cardboard up and down quite significantly. It will come into contact with the pot if it was, like, you know, bowed to shit, but yeah, as on this edge here it's just a ground plane anyway. It doesn't matter if it comes into contact with the metal part of the pot. So I think That's going to solve my issue. So now I can actually make up the PCB. Brilliant. And it's now the next day, and I've spent about the last 3 hours manufacturing these two PCBs, the volume board and the tone amp. Tone amp's in the bottom of the screen, bottom left. And I've already, after drilling it, tested it in the chassis, and yes, the edge of the circuit board does clear the potentiometer for the volume. So I fixed that problem. I'm just waiting for the lacquer to dry. Now, the thing is, this is the second attempt at making the tone amp board, because the first one, the resist, started washing off in the developer because I was trying to develop it in full bright sunlight. Never do that. So anyway, I'm waiting for that to dry. I'm going to assemble them, but I'm not going to bore you with the assembly process because it's the same as the videos related to these boards. Not much has changed, except I've shaved 8mm off one side of the board by moving components around. So I might put a link in the description to the videos of the tone amp being built and the volume board being built if you want to take them at your own perusal. But for now, I'm going to let them dry, fart, and clean up the floor a little. I found actually cutting the edge of these boards was a lot easier using my mini grinder rather than a hacksaw blade. Same method, use a piece of wood as a straight edge, but just run the blade up along the edge of the board to cut it and then finish it off with a file. What I might have to do is get a piece of angle iron or something, like 5mm thick angle iron as a straight edge, so I'm not cutting into the wood as much. Anyway, enough about that. I'm going to let that dry, assemble them, and then we'll come back once they're assembled. And there we go. About an hour and a half later now, maybe an hour, wasn't really paying attention. Both the circuit boards are now built, and I just got a massive hard on because I just went and test fitted these into the case and there are no clearance issues between the two boards. Win-win. Okay, it's getting late in the day and I'm wanting to do something else now, but wiring up the internals of the amplifier will be done in the next video, not this one. But before I end this video, I will first test these two modules to make sure that they're actually functioning, and then I'll mount them in the case and we'll have a look at what the final product is going to look like. Now, these shafts have been cut down. This one has not, because the larger knob that I've ordered is actually 22mm deep, so I'm not sure how much shaft I've got to cut off, if any. So I'm leaving that alone for now. But right now what I'll do is I'll test this tone amp board first, hook it up to an oscilloscope, DDS and power supply, and we'll just see if it is functioning. So I need an oscilloscope. That's not an oscilloscope, that's a toilet roll. Alrighty then, got everything set up. I've got the DDS set to 1 kHz 1 volt, and the oscilloscope is hooked up over the output, and we're on the left hand channel at the moment. All the controls are in the center. So as soon as I turn the load on, which is at 15,015 plus minus, I should see 2 volts peak to peak on the output of the scope. So I'm going to turn on the load, and I do. So as we can see, we've got an output there, so I'm just going to fiddle with the treble control. We see a mild increase, mild decrease at 1 kHz. Mid-range, significant increase, significant decrease. And bass, yeah, we're getting a slight change. I'm not going to go through the procedure of testing all the frequency ranges because that's a bit boring. That was done in the last video. However, just to confirm that the bass pipe is functioning correctly, I'm going to go to 60 Hz and play with the bass. Yep, bass is increasing, decreasing. So that's all I need to know. So now I can go back to 1 kHz and I can now go to the right hand channel. So to do that, I'm not even going to turn it off. I'm just going to swap the input around, and when I find it, swap the output around. And we also have an output. Okay, treble. Yep, I can see it's doing something. Mid. Doesn't seem as... it might be. I couldn't say if it was the same amount as last time. Bass we're not going to see much. Change the frequency again back to 60 Hz. And play with the bass part. Oh yes. Nice. Mid's not going to do much to that. Nope. Just for shits and giggles, I'm going to go to 16 kilohertz. That's 166. 16 kilohertz. Okay. And I want to change that trigger. Okay. And play with the treble. Wee, wee, yep. Treble appears to be working. I might switch back to the other channel and just verify that the treble's working the same. You know, just to cure my own insanity. Output. Yep. Very, very good. This circuit board is functioning and functioning correctly and fine. So now I can move on to testing the volume control board, and all I've got to do is just swap stuff around. So I won't be a tick. Okay, got the second board hooked up here, and it's much the same as the last test. Just going to feed a signal into it, measure it on the scope. Currently, with no load connected or it not turned on, we are getting a bleed of about 600 millivolt through the circuit, and that's with the volume control all the way down. So I don't think that makes any difference. Very little. But don't forget, both those op amps are running in inverting mode, so it's just a signal leaking through the feedback resistor network back to the output. So anyway, I'll turn it on, and the sine wave should disappear off the scope, which it has. So now if I increase my volume control, we should start seeing an output, which we are. And we should have close to 10 volt out, which we do. But we can't really see much voltage at the moment at the lower end. So I'm going to change the volts per division. About 10 millivolt, or is that 100 millivolt? 100 millivolt. We can see it slowly coming up. Slowly coming up. Yeah, so that channel appears to be functioning. So again, I'm going to do this live. I'm going to swap channels over. I mean, this is where a dual channel oscilloscope does help out a lot, but I can't be bothered hooking up the laptop and starting it up just to test it. So I'll try and get that to not short. Swap the oscilloscope over to the other channel. And currently at nothing. Little increase. And there we go. It's outputting. Now, as to what it's outputting total, .34 volt peak to peak. So there we go. That circuit is also functioning, so I am happy. And I'll just make sure to turn the volume control back down. So now I can disconnect all this and put most of the test equipment away and start putting these boards back into the amplifier. Well, this volume control board and the tone amp respectively for the first time. So yeah, let's get doing that. Okay, so I've got to figure out what I did with the pot nuts. I can't remember now. Well, that's a bugger. I took them off and put them somewhere. Now I can't remember where I put them. That's handy. That's real great. That is. Okay, so anyway, this board goes in here like that, and I need a pot nut and a washer. So I'm going to have to think what I did with them. Oh, I know what I did with them. They're in this stupid plastic bag. Okay, so I've got another 3-way connector. Nice. Okay, so you the washer on, and then that. I'll tighten him in a minute. And I lost the washer on the floor. And I lost that one on the floor too. I'll pick them up in a minute. Now when I actually tighten these for the final time, I'll use a spanner. But I'm just going to nick them up so they're tight. So they stop moving around. But they've got to come, well, two of them are going to come back out to do the internal wiring to the connectors, because, well, boards are in the way of the connectors and you can't get to them. So that'll be coming back out, but I'm just putting them in there now so we can all see what the front panel looks like. Well, without the panel on there, but what it looks like completed. And voila, nice. We've got a tone amp that fits. That always did fit, but it's now got a piece of insulation underneath its circuit board to stop it from making contact with the chassis. Got the new volume board in, and a little bit of a, oh, I know what that is, it's an on-screen display of the camera. I wonder what the hell that round thing was. Never mind. And all the LEDs and the switch. Yes, it's all coming together, and I'm getting a humongous erection. And let's face it, you would too. Especially if you had spent all day pissing around and actually had something at the end of it as a result. So anyway, that's with all the 3 boards in. We can't really see the volume control board anymore because this one's covering the top of it. The sub-bass processor, headphone amplifier on the bottom there, tone amp there. Sweet deal. I was going to do wiring today, but as I said, it's getting late in the day and I want to do something else, so that'll be in another video. But the topic still remains that the electronics have been finalised, and that was the whole topic of this video, was finalising electronics, and that's exactly what I've done, which was building the volume board and the tone amp. So all the electronics is done. The input selector is missing at the moment, but that's okay. So now I can work on wiring it, and then we'll do a sound test, and then we'll move on to the back panel and such and so forth. Anyhow, I'm going to end this video here, and I'm the Astro 30, and as always, if you like this video, please remember to comment, rate and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. I have no idea why I just started talking like this. I just did. Oh, fucking well. Yeah, the links are in the description as usual. And yeah, give this video a big thumbs up. Share it with your friends. So anyway, this is the Astro 30 saying, see ya. Have a great day. See you in part 8, I think we're up to next.